you remember, if you remember, I've been trying to set it up so that I can use my TV remote.
Hmm. Yeah, right, right.
Let me turn that thing off. That's kind of annoying. Um, my my TV remote here, so I can start the robot or stop the robot with the remote.
Hmm.
And it uses this little infrared receiver
Right.
that's connected to um, the a it's connected to a little microcontroller, the AT Tiny, and it's using two pins. One pin for goes to the microcontroller, the other microcontroller for initiating the start sequence. And the
Hmm.
other pin is connected to um, a relay switch, which if I want, I can just turn off power to the motors. So
Hmm.
that's the idea.
Hmm.
So that instead of using programming to turn it off, it's actually just shutting it down. Um, and I ran into an issue. Um, I was because I got everything working on the motors, and I noticed that when I revved up the motors and I went to go turn it off, it didn't work. And I was kind of frustrated about that. But I noticed on the data sheet that there is an optional filter um, that they have on there for a little capacitor to add to it. So I did that. I plugged in, I have a bunch of little ceramic capacitors, and I looked up, they didn't say which size to use, but I did look, I think it was a Google search, indicated that 100 nanofarad capacitor would do the trick, and it did. It just like now it works just perfectly.
Was that on the data sheet for your infrared receiver?
Yes, it was.
Ah, I see.
So yeah, so it filters out that noise, and now even if I have it going at the max speed, it still shuts right off.
Now, where did you put your infrared sensor on your robot?
Oh, good question. So I'm haven't got it placed on there yet.
Oh,
Right now it's still on a breadboard,
right.
and but I am going to put it on top of the uppermost platform facing up.
Oh, that's an idea. I hadn't thought of that. So just
Yeah,
straight and see, do you know how wide an angle it can handle?
good question.
You might find that you're holding your remote control up in the air, but that's better than nothing.
Yeah, exactly. Yeah. No, I don't know what the angle. It does have a little dome shape to the receiver.
Right.
Um, Holding it high enough should do the trick. I mean, um, yeah, I think that'll do just fine.
So, John, would you mind sharing a little bit about which how did you choose your relay? Okay, whether or
Okay.
not it's an already assembled um, interfaceable board or just a raw relay. Maybe you can talk a little bit briefly about how you made that choice, what kind of parameters that you looked at to match it with the motor, and details like that. If you wouldn't mind sharing that kind of information, that could be very beneficial.
Sure. Um, it's a relay switch that I got off of Adafruit,
Mm.
and I was looking for something that was modular, so I didn't have to do a lot of building my own.
Right, right, right.
And I wanted it to run right off of a pin on my Teensy, which is
Teensy.
3.3 volt pins. So they had one there. The only limitation on it that I have though is it's limited to 5 amps. Um, of current. So it'll right now it's fine for my motors because my motors are like uh, a little more than two for each. So right now it'll handle the current for the motors.
Mhm.
But if I do go to something bigger, it's not going to work for, or
Right,
at
right.
least it'd be tempting fate if I.
Yeah, right. Yeah, you could easily um over overload
Yeah.
overload that 5 amps. Yeah, definitely. Especially if that relay is handling control of in the case of 3 kilogram sumo, both motors in unison.
Mhm.
If that single relay is controlling or handling that on off of both motors at the same time,
Yeah,
that's
it
really
is.
going to be a limitation, you
So
know.
it's actually the power to the motor controller. So it's
Oh,
turning
okay. So it's
on and
going
off
okay.
to the
All
motor
right. So you
controller.
got an intermediary there. Okay. Okay. I see. Oh, okay. Right. Right. Yeah, and that's another thing too. A lot of these already pre-assembled modules, whether we're talking about relays, whether we're talking about motor controllers, and even some uh, power supply, voltage regulator kind of subsystems. A lot of them have enable and disable pins to them.
Mhm.
So you can easily enable and disable whenever you want to have that particular part active, and when you want to have it reading a particular signal or outputting something over to another part of your system. So that's always something nice too, to be looking for in your parts and your overall system design, as far as being able to leverage those enable and disable pins at structured times in your designs. Not that John had direct relevance to what you were describing, but I do think it's an important piece to consider for overall methodology, not
Mhm.
just for programming, but for electrical interface. So,
Thank you.
okay, that's good. Uh, okay. So perhaps we've got critical mass here. On my clock, it's showing 8 minutes after. And thanks everyone for attending today. I see that we've got like one new face. Well, really, it's not face. It's just a Zoom square right now. ARUP. If you wouldn't mind coming on camera and coming off mic and maybe introducing yourself to all of us, that would be fantastic.
Sure.
Ah, there you are.
Hi, so my name is Arup, and in my day job, I do semiconductor, computer architecture, performance analysis. That's my area of work. I haven't worked on microcontrollers in a very long time, but I'm just, you know, curious at what's happening
Hmm.
these days. Like, I mean, when I worked on microcontroller, that was on like 8052 and those kind of stuff.
Hmm. Right,
Like,
right, right.
but so yeah, so I'm just, um,
Oh.
yeah,
Okay,
curious.
so you
You know,
haven't done so really. So you've got some, you've got credible. It sounds like credible experience in the past and whatnot, but you don't necessarily have direct Arduino experience. Is that
I
what I'm
haven't,
hearing?
I haven't ever worked on Arduino. Yeah,
Hmm.
but
Right, right,
yes, but I,
right.
but mainly I work on like high performance computer, like superscalar
Right,
processors and stuff,
right.
those kind of stuff.
Yeah, understand. Understand. Okay. That's great. Well, we are very, very glad to have you here.
Okay.
And I just as a general FYI for all of us here, and I'm going to be sending out a meetup group message at the end of our session today, indicating that the overall structure, at least in the near term, at least through spring and through summer, is what I'm thinking, that the structure of these meetup events is going to be changing quite a bit as far as the topics themselves, and also the meeting day and time. And I won't bore you with the backstory on that, but I got some one-on-one direct information from some people who, at least in the past, have attended these meetups, and some desire to move in a different direction. And the main reason for this is the idea that what I had originally wanted to do for the session today, starting with month one of an RC vehicle convert series for like workshop, as far as some education and some quick wins for everyone. That concept was not taking off well within the group. There were very few to no RSVPs ahead of the event. So I took that to heart, reevaluated things, and realized, hey, the open discussion type of format, like the way that I restructured the event design for today and going forward, that's always been a popular draw. And so going forward, I'm going to be restructuring the meeting type for today, and then some related things that I've got in mind that are topicked and structured similar to that, is going to be the new change up. And the other thing I mentioned about day and time, I think, I got definitely feedback that Saturday afternoons is bad, especially now this time of the year for people. People are busy with other things. They've got other life things going on. So what we're going to do is we're going to do 7 to 9 p.m. Pacific time block starting in April. And I'm going to, for Thursday nights. Thursday seems to be a great night of the week in general for people to be free for something like this. And so I'm curious of what the consensus is here with the group members as far as moving towards that type of new day and time. And also the other thing that could be done for a new time block would be Sunday evenings, also say from 7 to 9 p.m. Pacific. So I don't know if people wanted to chime in as far as what their preferences would be for that. A Thursday versus a Sunday, and also in general, if you think that that you guys would like literally the events being restructured in these different, in this different format type. So I just, no pressure. If you don't want to make any comments either verbally or in chat, that's fine. But I just wanted to throw that out there that is coming in April. Okay.
Yeah, I think that's a better change. During the summer, especially, I think people are away on the weekends quite a bit.
Sure.
So,
right. Yeah. Exactly. Right. That's right. Thank you, Graham, for that input.
Yeah, I think last year I had a wedding to go to one weekend, and then I was traveling another weekend. And I don't know I can't remember if I just missed one or because it seemed like a lot got rescheduled too.
Right. I apologize for that, but there's been some unavoidables there.
Yeah.
Okay. Good. All right. Anyway, so we'll give it a try out. Things are flexible with this, and we'll see where things go. But I do definitely I've got a big passion for this topic and for continuance of hosting these events on a regular basis. So we'll see how things go, and hopefully we'll draw in more and a different crowd in moving to the weeknight type of format. So that's what I'm hoping. Okay. And so to that end, what I was thinking about today is, as I said, something more open-ended. And then with the idea that, of course, this is a help desk or a Q&A, a project sharing. things like that. It's all open-ended, no presentation planned on my side. And I'm hoping that people can leave, all of us, including myself, can leave with at least one new thing learned, one potential thing to take to their new project, to get something unblocked or to get working, based on everything that everybody is sharing back and forth. So as much as possible, it's always a good idea for a session like this to be open and open to sharing what isn't working for you, what you'd like to do as far as Arduino projects are concerned, and it's always smart to get your questions out there, and be specific, share what you've tried, and then we can all give our feedback in a non-deep dive way. I'll interrupt things if we get a little bit too much in a rabbit hole. But that's kind of the way that I'm thinking about this, at least for today's instruction, or not instruction, today's session. Okay. So I will, I know that Steve, last night we had an SRS meeting, and I know that Steve was planning on coming to this session today to talk a little bit about, he uses the Arduino cloud-based blocks programming environment versus what I use, traditional textual IDE type of programming development. And Steve indicated that he had run into some recent challenges with the Arduino blocks environment, looking for some specific features that he couldn't find solutions for, and all that kind of thing. So perhaps, Steve, if you're ready to give some presentation on that, that would be wonderful.
Okay. Hi, Donna. Hi, everybody. So I've got I wonder if I can, should almost.
And I did give everyone share screen privileges. So
okay.
You should be good to go that way.
All right. Yeah, it's this environment. Sometimes it can behave a little bit strangely, but okay. Let me see here. Right now. For some reason I'm not seeing when I plug in this. This is one of the little controllers. Let's see. Let's see, speaker view. Are you guys? Am I being highlighted on the big?
No. Well, I mean, you're showing that you're showing that you're. Well, the thing is, what we have, each of us has to do is go over like to speaker view versus gallery. Okay, so that's the way easily to get pinned for each of us individually, but that requires us individually within our Zoom application to go ahead and set that, to set it for whoever it is that's speaking, to have it on speaker mode. Then that way they're big in the screen and everyone can see the camera view easier.
Are you seeing me big right now?
Well, I will. I will now.
Okay.
You, and now whoever's speaking is big.
All right. So it should be. You guys all pop up big for me, so it should be. Seems like it should just do that. Maybe might help if maybe I'll switch to headphones here. So Zoom locks in on this. Let's see here. Get from there. All right. Let's see. Okay. Let's hear. You're all still hearing me okay?
Mm-hmm.
Okay.
Yep.
Okay. So this is I'm just all I see is my little thumbnail at the top, so I'm just kind of curious to what you guys would expect that you guys would see.
Yeah, like I say, if we individually set our viewpoint to speaker versus gallery, now you're in the large view, at least with what I'm seeing. You're in
Okay.
large view camera, okay?
Okay.
And I can
Okay.
perfectly see your board very, very crystal clear.
Okay. Thank you. That's what I needed to know. Actually, was whether that's. I normally I would have a second computer set up here that I could see what Zoom was actually presenting. So, okay. So this is a controller that on a kit. Let's see here. I'll grab the. This is an actual complete robot that has that controller sitting on top of it. So it goes together. It's like an erector set kind of a thing. So it's got these blue beams. It's got hex bolts and nuts and this particular robot has a two-wheel front wheel drive and a rear caster. And it's got a little servo on the front here with ultrasonic sensors, and it's got some other goodies on it. And you plug it into USB port on a Chromebook or a Windows PC or an Apple computer running the software that these guys provide. I have about 4 of these kits around. So this is just the board itself off of one of those kits, and it's actually running an RGB cycle. So it's like the lights on the top of it here. There's 12 of them. They're all just being run together, are cycling through the rainbow. So it's essentially calculating RGB values all the way from one end of the rainbow to the other end of the rainbow. And it's just going in a continuous program. So this is actually running on the Arduino. The board underneath this is a Mega 2560. So
Okay.
this is based on a Mega 2560. It's customized because it's got there's a couple of light sensors on here. There's a microphone built into this. It's got these 12 LEDs on this ring. It's got some extra buttons. These are like phone jack type ports. So
Yeah,
the
I was just going to
interconnection.
ask about those ports. What are those? What are those
Yeah.
for?
So the interconnections. So like on the robot here, you can see all these wires on top of here. So any one of these wires, you just got the little phone jack type of connection. So all the wiring for this kind of a kit is done using just these phone jack type cords. So it's it's a slick arrangement. It's actually it's a cool arrangement for getting kids started with this stuff because it's very simple. You don't have to do protoboard wiring or stripping wires or do any of that kind of stuff. So the programming environment itself, let me see here. I'll do a share my screen. And let's see, what do we want here? Chrome tab. Yeah, I think we'll do it that way. And okay, so now you guys should be seeing a tab on my Chromebook
there
here.
You go.
With
now we can see.
Okay, so I'm going to slide this guy over. So can you make out the actual instructions on there? Can you read, like this says when green flag clicked? Can you see that?
At least I can. At least I can.
Good.
Okay. So as you go down here, like this, for example, in these are variable settings. So these instructions, you pick. In this case, these are all variables that I've defined. You can go through, pick the variable, and then you can set the value. So this is the setup part of the Arduino program. Okay, the top of the program. You get all the way down. There's some stuff here, turns all the lights off, and then it says, stops motors if they're running. And then here's a forever loop. And then the forever loop, of course, is the main program that's just going to run over and over and over again. And this particular program, this is actually uses that ultrasonic sensor and does some other things. But I'm right now I'm having issues getting the Arduino to connect to this. So I think for the time being, I'm gonna load up this RGB program that I have here rather than that one, because then let's see, don't save. And you get this silly little panda. I get kind of tired of seeing him after a while. He would normally appear over on the left side of the screen, kind of in the middle of where these variables are. And I'll tell you about that in just a sec here. Um, okay, so let's see. There's a couple of things over here in the upper left corner. Let me see. I'll go to this one here. That'll make that just a little bit bigger. You can see here I've got variables named red, green, and blue. I've got a kind of a counting variable called RGB that steps through. It's a little hard to explain. 6 times the maximum RGB value that I'm choosing to use, and it increases or decreases the red, the green, or the blue as appropriate. I went online and I found a formula for this, and it says, okay, to get this particular color, you use you vary, usually just varying one color at a time. So you're either increasing, let's say red is either off or fully on, green is either off or fully on, blue is either off or fully on, and then you're picking one of the other colors and you're bringing it up from 0 up to some maximum value. And then when you want to change colors, then you pick usually a different LED, and then you're taking that LED. If it's already fully on, it stays on. If it's fully off, then you start to bring it up. And the result is then you get these different colors as it cycles through. So the program, so let's see, I need to shrink that down because it's kind of funky. So this is what they call their, this is their IDE, their integrated development environment, if you want to call it that. You've got the various instructions that show up here as the controlling the lights, for example, is in this show menu. Actions are things having to do with the motors. Sensing are the sensors. Events, in this case, there's the alternative. There's two kind of these different events where you click on in this case a green flag, red flag. If I'm interacting directly with the controller, then I put this when green flag clicked event start box up on the top. And in that case, I think that's what's actually up. Oh no, it's actually got the one this has got the one that's for loading the program and running it in the Arduino. Let's see, I'm gonna show you one quick thing too. So just out of curiosity, you might be wondering, well, how does this connect with the Arduino itself? Well, let me show you. So what it's doing right now is it's generating the Arduino code. So you can see over here on the right now, it's loaded some headers, it's included some headers. There's some light sensor stuff. It's doing some variable declarations. You've got a void loop up here, a setup loop, and then here's the forever loop down.
The while one.
Yeah, I guess it's doing a while one. I guess that's how it represents a forever loop.
Right. Yeah, that's the traditional in C forever.
Okay. And each of these, and then what it's doing is it's taking this RGB variable and it's incrementing it from 0 up to some preset maximum value that you set up at the top of the program. And the higher value you choose, it could be 0 to 255. Well, the higher value that you choose, the brighter the LEDs. So if you choose 128 instead of 255, then your LEDs it'll only go up to about half the intensity. And it's essentially proportional across 0 to 255. So you just choose a lower value to get less intense lighting on this thing. And it turns out the silly things are so stinking bright that on video, if I have this thing going to 255, it just looks like white to you guys. That's all you would ever see until, and so anyway, this program allows me to choose what that maximum value is. And I think the minimum that I choose is 32. So I can go anywhere from 32 all the way up to 255. And depending on how bright. And then what I do with this guy is because I use one of these light sensors to calibrate that. So I say, okay, based on the ambient light, the brighter the room is, the higher the value, the brighter the LEDs. So at night, you'll get a much nicer, more gentle, lower intensity lighting. And then in a bright room, I've got my window here faces kind of southwest, and at this time of the day, it's quite bright when the shades are open. And so, in that case, to be able to see the colors, you need this thing to really be blasting the LEDs. So anyway, what you can see over here is essentially the code that resides, I guess, inside, however you would describe it, for this block code. So it's convenient. It's convenient because you don't have to worry about the syntax. You don't have to worry about closing curly brackets, making sure you got semicolons at the ends of lines, things like that. And I think the Arduino environment, I think, does a lot of that for you, I think, doesn't it? So it kind of helps you make sure that you complete instructions properly and all that. The nice thing about this environment is you can actually do this stuff while the program is running. And see if I can get this thing to hook up. So one of the things that's a little bit odd right now is there should be a second serial device showing up here on the list, and it's not. So if I unplug the Arduino, you notice that item at the top does not disappear, which it should have. When you plug a device in, it just flashed on there for a second. I don't know if you saw that. It came on for about a second, yeah, and then it went off. And I don't know what's going on with that. It's some kind of a weird USB. It's a USB thing, I think, and that's one of the things that see, it's like it's not letting me. It should be letting me see that and then pick that, and then that's the serial port that gets used by the software. But until it'll let me do that, it's not going to let me talk to this guy. And I am not sure, what's going on with that. The last time I ran into this, I literally had to power everything, power it off completely, bring it all back up again. And, I lose my Zoom session and all that if I do that. So I might just pass the baton to somebody else for a while and actually do that and see if I can get this working. But
so that complete reboot, turn everything back on, reinitialize everything. That method has worked in the past as far as getting it has.
Yeah,
okay.
as far as getting this working. What I'd love to show you guys is the interactive. I was talking about last night about like being able to view data on the Arduino as a serial data stream. And
right.
And within the Arduino environment, you have the monitor window that you can open.
Right, exactly.
And then you can send data from variables or whatever you want. You can send stuff to that screen. This environment doesn't seem to have that kind of a mechanism. I don't know. I don't know why. I think it's a deficiency. But when you do the live interaction thing, which is a unique feature, you can literally change program steps. I mean, you can take blocks in, you can take blocks out while the program is running, and it will interactively show you the effects of that. And
now, Steve, when you're doing that, is that program that you're modifying, is that running on your PC or is it running on the Arduino?
I think it's running on the PC or the browser. I believe it's running on a simulator off board, so it is not running on the processor itself.
So because you don't. When it runs that way, it's sending individual commands to the Arduino to make it do the things that your program wants it to do.
Exactly.
Wow.
So you will see. So it will interact with the I/O ports, like these ports on the side of this thing. It'll actually interact with them. So if you've got motors plugged into these guys, it'll make the motors go. As long as you have power, you have to have. There's a separate power plug on the back here. So you got the USB connection, then you've got your motor power essentially. So you have to have both of them present in order for motors to work. But you can have a servo hooked up to the thing. It's because the USB will power a servo, and then the servo will sit there and it'll respond. Mm-hmm. So you have that ability, and then this area over here on the left has places, these shows you all the variables. You can choose whether you want to see them all or if you want to just see particular ones, but you can actually see the values of your variables over here as you're interacting with the program. And if I go over, say if I just grab a, like here's like I broke the program right here now. So I've separated it. If I want to, I can take another piece down. You have to pull them a little more than one instruction width apart. And then I could, let's say I wanted to insert something, like let's say I'll take this weight off of here. Let's say I wanted to put a second weight instruction in there. Okay, now I've duplicated that instruction, drop it in here, drag this back up here, and then bring this guy up. Okay, now I've inserted 2 weight instructions. You can do that with anything. You can go in and you can just pick and choose, add and delete, whatever you want. And I'd see I didn't show some of this other stuff like variables, for example. When you got a variable here, if I wanted to change one of these things, he says those are numerically typed. When it's a white bubble, you type that in. But if you want that to be a variable, let's say you go grab a variable, you drag it over, and when you see the little highlight appear around the bubble, you can drop the item, and now it drops that variable into that instruction, and now that instruction will respond to that variable instead of the original. And then I can just grab it, move it out of there if I don't want to. I can right click on it, I can duplicate it, or I can just say delete, and then it's gone. Mm-hmm. So now in order to get rid of this extra instruction, I have to break the program apart and couple like this, take that guy like that. Now I can delete that one block. If I leave things connected, then it will delete big chunks of stuff. Donna, you had a comment?
Oh, there? I was just going to make a suggestion.
Sure.
Based on what you'd shared last night, mm-hmm. for what you want to do and what you're showing us right here live today. Yeah. Since this environment does generate, now I'm not recommending that with the code, with what it is that you're not seeing fully, being that you have to not uninstall. You have to do a full reboot and then get hopefully everything back to a stable state again. Yeah. Maybe from that point, maybe you can do something what it is I'm going to advise right now. Mm-hmm. One thing that I would recommend, do you happen to have either on your Chromebook or on a different PC that you have available for development? Do you happen to have a PC that will allow for the traditional Arduino IDE to be installed and set up? Because the reason why I'm suggesting that, mm-hmm. Since you do have available, at least in partial sections, the Arduino developed code, right. the actual code for the GUI that you're developing here.
Yeah.
If there's a way easily to copy that code, save it off or compile onto the Arduino IDE, and then try and compile that way, even something separate from what you're doing here with blocks. Okay, and then you can go ahead and you can see you can do some analysis as far as that serial monitor, as far as inputs into this through the serial monitor, and then also the data that you're expecting out. Because what I'm wondering about, and then you can do some experiments that way to make sure that the code itself that's actually running physically on the board that you were showing us, make sure that on the robot with the connected hardware, that the actual code itself is functional. What I'm thinking about is that maybe it's a problem that way as far as the code itself not being generated correctly or completely versus the idea of something visually within the M block environment. That's what it is I'm wondering about.
Yeah, that's a possibility. I've got it's an old Windows 10 PC next to me over here, which of course, as you know, Windows 10 is that's been sunsetted by Microsoft. And I've been avoiding going out and buying another computer, but I might be compelled to do so, whether I like it or not, if I want to keep going down this path. I thought about doing exactly what you had talked about there, because yeah, it's fairly easy to go into that little window that was generated. Just basically do a select all and copy,
Yep.
go
Yep.
over into the other environment, drop it in there, or drop it into just a text editor, and then just
Yep.
save it as
Exactly.
an INO file,
That's
and
right.
then just pull that into
To
the environment.
into the
Yeah,
ID Arduino IDE.
right
Yeah.
in the Arduino IDE. Yeah, yeah, and that I was kind of hoping, because I'd like to be, trying to use this thing as a teaching tool for kids. I would love, it'd be nice to be able to stay within
Oh,
the same
sure. Oh, I
environment rather than
understand. I'm
having
just
to.
trying to.
Yeah,
I understand. I
yeah,
understand, Steve, what your desire is, and I think that
yeah,
that's commendable. Commendable.
yeah,
But the thing
yeah.
is to try and isolate exactly
Understand what's
where the
going on.
problems are.
Right,
Okay, with
right.
all this, I'm just thinking about maybe you should back up and try debugging this from a different vantage point,
Yeah,
and
yeah.
to really find out, to help identify, because it seems to me there's a bunch of different things that could be
Yeah,
amiss going
yeah,
on here. And so
yeah.
if you can isolate in any one or group of problem areas, that's always advantageous to try and figure out what's going on.
Right, right.
What is
Yeah.
that devices tab? Like you have the Arduino and MBOT, and the one's got the X in the corner, and the other
Okay.
one doesn't. So is that highlight to highlight one or the other?
So what this is? So let's see. There's a
So if you
portion.
select the Arduino, does it get
The
the
Arduino. Yeah, it's so Arduino in this case is the Mega 2560. And what that will do is that actually changes these instructions slightly.
okay?
So these instructions, the instructions for the MBOT robot itself, as far as, like, for example, when you say sensing, there's a light sensor. There's actually two light sensors on that board, and so you're given a block that has those two sensors, and then it also has ports 6, 7, 8, 9, and 10, which are the plug sockets on the side. So in other words, you can bring
Yeah,
in an external, and so these instructions, like the sensing instructions, the let's see, the action instructions, which are the motor related ones, are also customized because the Mega 2560 doesn't have any motors. So, but this kit, because this kit does, you're given blocks that allow you to control the motors that this kit comes with,
right.
and so depending on what you pick, and then if you way over down here in the lower left corner, you'll see there's a plus button down here. So now if I pull that up, I get a device library, and now it gives me the option to choose a bunch of different kits that MakeBlock makes,
Right.
including my Ranger here. There's a little simpler one that they call just MBOT. And if I keep scrolling down, I get various Arduino configurations. Here's the Arduino Mega 2560, the Nano. Here's the Arduino Uno. So you choose one of these, and then the instruction list will automatically be customized to match what that particular processor can handle. And in the case of the Mega and the Arduino Uno, your I/O is really just pins mainly. You can take this pin, you can send a servo signal, a servo type of signal, pulse width modulation. You can set it to as an output. You set it as an input, things of that sort. So depending on what you're how you're interacting with it, you get they've set this up so that it can interact with a lot of different devices. I mean, it's a very extensive library here that actually just goes on and on and on. All these things that it'll do ESP8266, it'll do ESP32. There's a lot of different devices that this environment can work with. I haven't tried some of these other ones, and like here's got an Arduino Nano Old. I don't know exactly what the difference is there, but so you can load those up, and then when you save when you do the file save up on top of here, this is all preserved along with whatever devices you've selected get everything gets saved. The whole environment gets saved off into a file that can then be pulled up later. And you can save it onto a hard drive. You can save it onto a thumb drive. You can save it into the cloud. There's various places that they give you to do that.
So when you upload the code, are you uploading it strictly to the Arduino, or do you specify the MBOT and upload separately to that?
You when you want to do an upload, you choose the device that you're plugged to. So in the case of this thing is considered an MBOT, even though it's just the controller. But I would have to have the MBOT Ranger selected down here in the lower left corner.
But it does have the Arduino inside it.
Yeah, it does have the Arduino. So all the instructions that execute are all Arduino compatible. It just has the added layer of the specific hardware, the hardware devices that this thing is connected to in the kit. So it comes with a kit that has a bunch of stuff in it, and then these instructions, this got these additional instructions coded just for that kit. And so then you can grab like with in the case of the LEDs, for example. Here's how you can control all lights up with color, and then you've got 0 to 255. Essentially, you've got your red, your green, and your blue, and so it's all set up for you. You don't have to go and figure out, well, how do you actually communicate with that? Because if you look in the documentation, people have gone and figured that out. It's like, what is the actual exact Arduino instructions necessary to communicate with this kind of a device, and how do you control the individual colors? Well, this environment is set up so you don't even have to worry about that. Just plug in your numbers, and it'll just do it. And so it's slick in that regard. It's like they're taking a lot of the tech and they're just super simplifying it, kind of making all of this stuff sort of under the hood functionality, so that all you get, it presents you with a nice clean interface. Just do. So, go ahead.
What part is not actually working then? Like the upload or the?
Yeah, well, right now it's not recognizing this guy when I plug it in. When I come over here where I go live, and then serial. So the serial connection. So this is my end. I got to figure this out. So right now, this window that you see that just popped up there, it is showing that, right? You're seeing
serial connecting.
Yeah. So there should be 2 items there. I don't know why it does this exactly, but it probably happens too quick for you guys to see it. But a very brief USB serial and then a device popped up below what you see on the screen there for about a quarter of a second, and then it disappeared. And that is this device, but for some reason it's not staying up there. So I think what I have to do is I have to kind of reboot all of my stuff on my end and get that, so that, because then I can pick it, I can say, connect to it. The environment will hook up to it, and then I'll be able to do most of the other functionality that I could normally do, but is not working for me at the moment.
Because like even on our IDE, I think you have to specify which, what is it, COM port or something like
typically.
that? Yeah.
Correct. Yeah. And this is kind of like that, except it's really just, it's pretty obvious. It says USB serial port something. So it's pretty obvious. Okay, I'm hooked up to a USB serial port. Yes, that's definitely what I need to do. So it's
but does it still need to know, is a USB 1, 2, or 3 kind of thing? Or
I typically only get an indication on the device that's there. Actually, that's an interesting question, because I've got a bunch of USB ports, but the only thing I'm seeing is this TTY MSM0 and the whatever this guy is. Well, it's right at the very top. Are you seeing you should be seeing, let me see if it's I'm all I've got is let me see if I pull that. Yeah, I wonder if you are seeing that. Let's see. You should be seeing. Did a box just pop up? Are you seeing a box pop up?
We saw something flash, but
That's
it was
it?
too quick to.
Okay. So what it is, it's just a little box on the top of it. It says IDE.mblock.cc wants to connect to a serial port. And then it's listing, and it's a box that's showing some choices. And the one that's there, if I pick the one that's there and I connect to it, it says connected.
Right, we
But
see that.
okay, but when I go, I'm currently in live now. When I'm in live, I should be able to say, "Oh, okay, go ahead and start running your program." Well, it doesn't work. So,
Hmm.
because what I should be able to do is I should be able to run interactively with this. Well, let me see. Maybe it's just acting wonky on me here again. Let me try something. I'm going to get rid of that. I'm going to do a little bit of little software surgery at the on the spot here.
Hey, Steve,
Yeah.
I was wondering, does the device have access to more than one serial? Because
Um,
there's like four of them on the Mega. I don't know.
yeah, but it's the way that they've set it up. They've only got the one serial port on the end here, the one USB port, and I think they just call it there's serial, and then there's serial 2, 3, and 4, and the others are other ports on the side of this thing. And so when you're hooked up to the USB port, that's like just the serial, what they call serial port. So it's um let me
Just try
see here.
clicking on live again. It seems to be,
Yeah.
what's the setting to?
Well, so there's actually probably, well, okay, so there's, yeah. So there's another thing. There's another layer to this that I haven't mentioned, which is, so right now when you upload code into these guys, your program takes over the memory, the non-volatile memory in the controller, and that's what it does. Your program, when you plug the thing into power, turn it on, it runs your program. If you want to do this interactive live thing, there's a function here that's kind of buried under this. This thing is up here. It says, I don't know if you can read it. It says update
Update
firmware.
firmware, yeah.
Yeah. And so what that does, okay, now that brings up this little box, and you click on this, and what's supposed to happen at this point is that it should be uploading a special
Oh,
program into the Arduino that allows this live interaction with the platform.
So that's what
So
I was
that,
talking about before, that
yeah.
everything your program wants to do has to have the other end of it on the other
Mhm.
side. And that's what this is. This is
That's what
firmware
this is.
that
That's right.
supports that connect.
So the firmware essentially is what enables the make block hardware, or actually anything. It'll work with the Mega 2560. It works with an Arduino Uno. They have a version of this online firmware, as they call it,
Right.
that will go into your processor and then allow your processor to interact with the environment. And for some reason, it's it's just, like I say, there's something in the communication that's broken at the moment. That's the problem, because this should just work. I mean, normally this is
Yeah.
very reliable, but once you put this firmware into your processor, whether it's your own Arduino or this guy, now the live function works. The variables up in the corner here show up. You can see the values of your things as your program executes, and everything sort of functions, as if it functions as a virtual Arduino. So as you would suppose, Doug, you're not actually running on the Arduino. You're interacting with the Arduino using their firmware, whatever that firmware exactly is. And
So now, Steve, what
yes.
what feature? See, they have decided that they get so much additional functionality by running on the PC and having this interface to the Arduino, uh,
Mhm.
that they have not supported the other mode that you wanted. What is the feature that you would get from that other mode that you're not getting from this?
what I would like to be able, I think, now then you can tell me how useful this is, but what I would like to be able to do is I'd like to be able to put my program into the Arduino and then be able to monitor the Arduino over the serial port, the way
Okay.
that you would when you're in the Arduino CC environment. And you because
So,
you
but you're not telling me what is it that that is doing that you're not getting from running it on the PC with the interface?
well,
Is it the performance?
yeah, when the program is running on the PC, it's very slow. So
Ah,
you're not getting a real time execution at the speed of the Arduino processor. It's running as simulation. So the variables change at a very low rate because it's everything is slowed down because it's running in a simulator, not running in the actual processor.
right.
So functionally, you can verify that your program does everything that you expect it to do. You can see that variables change, everything should work. Then you take your program out of the simulation environment and then you upload it into the processor, and then you can pull the USB plug and it should just run. But if you wanted to monitor what your robot is doing by being able to plug into the serial port on the Arduino and go back to a computer, you need some other. No, I guess you need. Well, I don't know. I guess that would be true even with the other environment. You need some other kind of a tool to allow you to see data on that serial link. I guess maybe I'm not really understanding how that would be done in a more standard traditional way.
Well,
Maybe.
so you wouldn't want to have your students do this, but you can do it. You can um, uh, have all the functionality that you want, uh,
Mhm.
and do all your debugging with the code on your PC. And then when you get to the point when you'd like to download it, I think you could read through the Arduino C that it generates,
Mhm.
find out how it handles. Um, yeah, it's not going to be the same though. I don't know how you can do that.
Yeah.
You have to go through and modify that program so that when it runs on the Arduino, um, it is then sending out. Basically, you have to run it on the other environment, the other IDE.
Yeah.
That
Yeah.
gives you the connection. But I don't see why you'd have to do that on a different computer. Can't you just install Arduino IDE and run?
Yeah. Yeah. Kind of. I mean, I'm doing this on a Chromebook.
Okay.
So
Oh,
okay.
so is that
Okay.
hard to run on that?
So on a Chromebook, you have to run it in a essentially a cloud
Oh,
version.
oh,
You run it because you're basically just running a web browser, right? So the only software is running through a web browser. You're not running an installed program like you would on a Windows computer or a Mac computer.
so that's
So
why this is so slow because it has to actually interpret Arduino
It,
C basically,
yeah,
probably running in JavaScript or something like that.
yeah, that's my guess. But actually, I might be kind of overthinking this though, because it might not actually be that necessary for me to get to this other step because I'd really love to demonstrate the actual simulation running on this thing for you, but I'm going to have to reboot my computer to get there. So, um, but I've been burning up a lot of your time, Don. I don't know if anybody's got any more questions, I can try to answer before I do that. I would
I,
love to.
I, I just I just have one other question, Steve.
Yeah, yeah.
About okay, so if you are successful in rebooting, getting the connections that you were expecting that you're not seeing
Mhm.
right now,
Yeah.
my question is, have you at some time in the past been able to successfully connect that online firmware, as they call it,
Yeah.
via the update firmware button? Have you ever been able to get that to
Oh
a
yeah.
success? You have.
Yes.
Okay.
Yeah, that does work. I don't know why it's acting like this now. I'm running this thing on a let's see, that is plugged into a hub connected to a USB connection on this Chromebook. So you got the, it's a port, basically a port multiplier, right? And sometimes those ports can get a little confused, I think, or so it may have something to do with that. I'm not sure. It's actually normally works fine. I mean, I've done this process many times, updating, putting the firmware in there, putting my program in, going back and forth. That always generally works pretty good. So, but for whatever reason, it's just been, kind of acting weird.
The only other thing that I would suggest to help with your number one, to understand this environment that we're looking at right now better, and to help you maybe find a way to solve what you were talking about last night with this environment and the robot. Perhaps if you can find online, whether we're talking about Meetup or not, there are a lot of, with the popularity, I imagine, of this environment that you mentioned before. I would imagine that there are a lot of topic groups that, in theory, online type groups that you could join
forums
to help. Right. I don't mean necessarily forum. Well, forums might work as well, but I was thinking about actual virtual events that you could sign up and attend, where you could directly ask these types of questions, and to be able, since you had communicated before that the user guide and user information is really not up to par with this. And so perhaps you could also investigate the other training options, is what I'm getting at.
You're probably right. I mean,
versus trying to, just sitting and spinning your wheels trying to get something to work when it's not, when things are not fully understood, and that maybe it's a solution that's right in front of you and you can't see it, is what I'm getting at. I mean, heck, we all encounter that. That's not a deficiency on your side.
Right.
So is that M block fully freely available, or do you have to buy
it is.
their kit?
Nope. There's the environment itself. The environment itself is located up in the address block there. It says IDE.mblock.cc. You see that at the top of the screen there in the address bar?
No, we don't get the address bar, I don't think.
Oh, really? Oh, yeah. I think. Oh, you're right. It's not. Yeah, I see. It's not showing. Okay. So ID is in David, Edward, .m is in Mary, block.cc. So just take a web browser, go to that. Usually Edge or Chrome are kind of their recommended browsers to use. Go to that, and it's just there. And it'll
work with the 2560 Arduino or whatever.
You can play with it. You can play with it your heart's content. There's no cost. It's helpful to set up an account, because in order to save things to the cloud, you have to have an account. But if you don't want to do that, you can just save to my computer and then plug in either save it to your SSD or plug in a thumb drive or something like that, and then just save your files locally. And so it's it's freely available, and you can play with it to your heart's content. And it's like I say, it's slick. I mean, it's slick, and I've done programming in the Arduino environment, and it's I'm not a professional programmer by any stretch of the imagination, but this block stuff is so ridiculously simple to do, and it's really easy to convey. The bigger challenge of conveying programming to like, say, 8, 9, well, maybe 9, 10, 11, 12-year-olds is the concept of creating the program itself. How do you think through what you want for a program to do, and then formulate a plan to accomplish that? Because the code doesn't the blocks won't write themselves any more than they will in an Arduino environment. You still have to know enough to be able to create your program. But this makes it so easy that you don't have to worry about the syntax and the any of the details, really. You just grab your block, just plug your blocks together and put them in simple loops, and they only give you a few looping structures because that's really all you have available, and it takes care of closing loops. It takes care of setting up your variables and all this kind of stuff, and all you got to do is just stack the blocks, say run, and off it goes. So
Steve, what was that address again? IDE.mblock.
.cc.
CC.
Okay.
Yeah.
And that's a web address then.
It is.
Doesn't sound like a web address. It's like CC instead of com.
Yeah. I don't know what to.
I think that's a country code, maybe.
Yeah.
So the Arduino, when you go to Arduino.cc is the same thing, right?
Oh, okay.
But when you do it with Arduino, CC has a cloud-based development environment that you can use with a browser. However, it's severely limited. Severely. I mean, you get very, very little in terms of sketch development and number of compiles and other things. I think you're extremely limited unless you actually buy a subscription, and then you can get a much broader base. Oh, and there are header files for this controller that you can install in that environment, in the Arduino development environment, that allow you to communicate with this device. And the headers know about all the I/O, the special sensors and other I/O that this guy has available. So I've not done that either. That would be, again, do this on a Windows computer and install all of the libraries that go with this device, and then I could do the development with this program, with this processor in the standard environment, I'd have all of the instructions essentially that you need to talk to the different I/O pieces. So
I've never seen or looked for it, but imagine a box that you could plug a USB cable into, and then get another similar USB cable and plug it on the other side of that box and go to your microcontroller. And so what this box in the middle would do is spy, right? It would send all of the information through both ways, but it'll also let you look at what the protocols were being used and stuff.
A little bit like I remember they used to have emulator pods for processors that you could plug. You'd plug it in. It would plug over the top of, or it would plug into the CPU socket.
Right.
And that device went back to a computer that would allow you to see all of the internal registers of your processor and see everything that your processor was doing, single step through things, set breakpoints, all that kind of stuff. Some of you guys might be old enough to remember some of that kind of hardware.
Put a version of that processor into that circuit emulator.
Yeah, essentially. So
now that thing that I just mentioned, a box in the middle, you could do that in software as well, but you'd have to how?
Yeah. It could probably just have a little Arduino in there doing that for you, a little Nano or something.
Or I guess in this situation, what I'm thinking is, imagine software that would hook itself in to the IDE controller on your PC. And so it would allow you to spy. That sounds like someone would have written that there's open source code somewhere that you could find, but it would take searching. Maybe an AI could find it.
Yeah, could be. So,
another thing too, Steve, you were mentioning, and Doug as well, about that spy or interceptor or pod type of thing. So just as an FYI, one of the things that you're talking about there is what's called an ICE.
Yes.
So it's
emulator.
Right. In-circuit emulator. Okay. And so that's still a very relevant, at least, especially for professional embedded development. Those are still very, very relevant
It
and
says go ahead.
prevalent out there.
Wow.
And of course they're expensive,
Oh yeah.
but it's something that if you're using something other than the traditional Arduino IDE, or you're using something different than Cloud Blocks development, or you're
Mhm.
using something different than this environment here, Steve, that you're talking about.
Yeah.
If
Yeah.
you upgrade and you do a more professional, or you use a more professional development environment, say Atmel Studio, say Platform IO with VS Code, those types of things, you
Yeah.
can easily embed or well, you can easily hook up those systems like ICE or even virtual emulators to debug your code. Ultimately, I think that's what it is that mostly, Steve, that you're getting to, is the idea
Yeah.
about being able in this environment here, being able to visually debug your code.
Yeah.
And
Yeah.
so what I'm getting at is that even for the Arduino line of PCs, anything that's of the AVR line, there are still ICE environments that are still around. So I just wanted to throw that out.
Okay, so I remember those from years. There was a point in time when I was actually selling those things way back in the 88X in world. You know, you had 8085s, 8086s, 8186s, 8286s. You know, remember all those different processors in the early days of Intel, and yeah. Yeah, and you know, it just occurred to me that I've got another computer going here, and I'm thinking I'm going to try hooking my pod up to that and see if I can get it to work over here, because then I can share from that computer. See if I can make this thing work. So if somebody else would like to chat for a while about whatever.
I will ask you, Steve, to go ahead and stop screen share.
Share. Okay, I can do that. Yeah.
Okay, cool.
There we go. Okay.
All right. Okay. So whomever would like to go next, sounds good.
Well, I can show the progress I've made on my 3 kilogram sumo.
Cool.
See here.
Yeah.
I have some pictures.
Oh, nice.
If I can.
I always loved how aggressive those guys could be. 3 kilogram sumos can be just they're like combat robots, you know. I mean, they can really go at each other.
Yeah.
Yeah.
Can be very dangerous.
Yes.
You know, flying pieces and
flying pieces. You really do have to start thinking about arena containment. When
exactly.
You start, working with those guys. Yeah.
Yeah.
Well, I was thinking about that when John was saying that he's opted for a relay to really be sure that he has shut down his motors, because you could imagine an enable pin on the motor controller. But he doesn't want to trust that. He's put a relay in there to actually depower the thing.
Yeah, or like a pull-out plug disconnect, you know, so there's no way that power can get to your motors.
I'm having problems trying to share.
Oh, well, okay. So in other words, share for you, John, is not even showing. Is that what you're saying?
Got the share. I selected it. And it has whiteboard docs. And then it gives me 2 other ones. I can try this and see.
Well, what should be available is like the entire screen. Like right now, I just clicked on my share window that just popped up, and you can either do application windows that are applications that you've got running, or the entire screen.
Yeah.
There we go.
Okay. There
There
we
we
go.
go.
Now
Yep.
we got it.
Oh, nice.
You see, I don't know what you see.
We
But it looks good.
we see obliterate.
Okay, that's the one. So that's the one I'm building.
Wow.
The render,
Litter. Oh, and an 8. Okay.
Obliterate. Yeah. I like that's I like that.
in at the top, I haven't actually, I have the information I'm gathering on GitHub, and that's the address you can see at the top there. If you can read it, it's
Mm,
GitHub
Jennings/3KG Sumo.
uh,
It's the,
3kg.
um, this is the inside. This is taken off the hood and looking inside. Let me see if I can. Oh,
So
there it
that's got to be a 3D printed block you've built there.
yeah.
is. So I ended up taking the battery apart too and putting on a smaller wire because had this really, I didn't need
Hmm.
something to pull that much current. So I put in a smaller wire for the battery. And then it's got two voltage regulators, a 5 volt here, and then a 12 volt here, and then there's the relay switch.
Oh, yeah.
And then it's plugged in over here to a fuse and then the start switch that's on top of the lid.
Mm.
And so yeah, this is the relay. It's got it's just operated using 3.3 volts and it's in series with the 12 volts going to the motor controller.
Right. I'm trying to figure out your slanted sensor ports. Where do the sensors live in that?
Well, they're not there yet.
Oh, they go on the outside.
They
Okay.
go on the outside. There's one here. You can see one
Yeah.
right there, and then the other two will be there.
Really cool.
So where's your teensy board at, John?
That's on top. Um,
Need a different picture. There we go.
so this board I just purchased for controlling the motors. It's it's for 10 amps max,
Ooh.
and it's got a nice little switches here you can test the motors with. It's and turn like forward, reverse for both sides. And then for my teensy, I have another board over here that I have the teensy on, and I've got the encoders all wired up to this board. And those are working great. I have to the motors are 5 volts required for the encoder, so I had to use this
Level shifters.
shifter, yeah.
Hmm.
And then for the infrared sensor or infrared receiver, I have it's getting data, sending data to this little AT Tiny here, and two of these pins are used. One is connected to one of the pins on the teensy for starting the routine. And then the other one is connected to this wire here, which goes to the relay switch for powering it down. So basically I'm using this for start and stop.
So is this a custom board, this purple board?
Yeah, yeah.
Hmm.
I've been using Osh Park forever. That's the only place I've ever used. That's they make their boards purple color.
Hmm.
I used this switch here for different modes. I can set up different modes for operating. And I have it right now. I'm using, each switch is connected to its own pin. If maybe in the future, I'll use some kind of resistor ladder to 1 pin kind of thing. But right now I'm just using one for each. And then another start button in case I want to use just a don't want to use remote. I can just go with that button there. Let me make it bigger here. Oh, there we go. And so right now on the Teensy, I have a program running that just receives the PWM number for whatever motor I want to run, and then it reports back the revolutions, the RPM, which is eventually that'll of course it'll be different, but right now that's what I have running on it. And then a couple little LEDs, a green and a red one. And when I put these on there, wasn't thinking about there already being one on here connected to pin 13. So now I have two LEDs connected to pin 13. But and I think so the next part is just connecting up the sensors. I think I have a picture of that here. So yeah, so this is that infrared receiver with the I mentioned earlier at the beginning of before we started, I was talking about this little capacitor that I needed to put on there, and I didn't know I needed to put it on there. Otherwise, I would have put it on the board, but before I actually had the board made. But it's a little filtering capacitor because when the motors were revved up, the infrared receiver was not, it was getting some garbage data, some noise coming from, and so this little capacitor smoothed everything out, so now it's working well. And this little one here is going to be for the line sensor.
Okay. That looks like probably a Pololu or a parallax part.
Yeah, it's a Pololu.
Yeah, Pololu.
And it's got 4 pins instead of some of them you see you'll have 3 pins, power and then a signal. Evidently, I haven't even played with this yet. So, but evidently one of them you can actually control the brightness of the LED. And I think, okay, what do I got next here? Oh, I've been working. I don't know if you saw, I have.
Oh, that's your mold for making your wheels.
Yeah. So I have the wheels done. So I ended up printing the wheels. This was the first one. I ended up doing some other ones that actually these are printed in a dovetail shape.
Oh, wow. So it really grabs them.
Yeah, so that when the rubber's poured in there, it really hangs onto that, hangs onto the wheel. And so,
so your 3D printed base actually holds the sides in there. You don't have to actually clamp it or anything. That's very cool.
yeah, I do clamp it anyway.
Oh,
Yeah. I take it all apart and put a little layer of silicone between there and on the bottom and put it together and let it dry. And then when I do the next, when I do the next pour, I know it's not going to leak. And then let's see, I think, there's one more picture. Oh, yeah. So,
so I just realized your scoop is the traditional where you flip it up to get with inside the bounding box.
Mm-hmm.
and this render here just looks like it's glued on there because I didn't know how I was going to do that yet. So this is my plan for
Right.
hinging that, making this little hinge here.
Hmm.
And I'll probably, so this thing here, this piece here, the hinge piece, slides right into this. Oh,
Mm-hmm.
I call it a blade. Um,
Mm-hmm.
it'll it's it just slides right into that little notch.
Hmm.
And I'll probably, I was thinking of gluing it in there, but my second idea is to probably just put a plate over the top of it, oh, and screwing it, putting that way I can take it apart if I want to.
Yeah.
Well, and it looks like that could break during a bout.
Oh, this right here.
Yeah.
Mm-hmm.
So this will be, yeah, I'm gonna solder that in with some silver solder. I don't
Ooh. Oh, that's metal plate. That's right.
could
Under
make this longer to make sure I got like more, but this is a 2 millimeter rod, um, brass rod.
Okay.
It'll be soldered to this
Oh, yeah.
thing. So that's what's going on with this so far.
Very impressive, John. Love it.
Yeah.
I was able to get I've got a second computer running over here, and it communicates with this module just fine. So I can
Okay.
actually demo what I wanted to do before.
Oh,
So
okay.
good time
Unless
for that.
somebody else wants to do something besides Steve K2 over there.
Yeah.
Then we can go ahead and we can do Steve if nobody else has anything.
That good, everybody?
Okay. All right. Cool.
All right. Okay, so let me get up here and share this. Share. Let's see. That guy. Turn that off. Share. Okay. So it's now. Let's see. I'm going to go ahead and Whoops, wrong computer. There we go. Okay. Okay. So now, so you see the yellow outline that tells you what's actually running. So when it's when you see I've got the other block atop there. It says when MBOT Ranger Ariga starts up. So you swap those two blocks out depending on whether you're running it live, which is when green flag clicks, or when you're running upload, then you do the other one, the grayed out one. And so it's actually showing. And if you look up in the upper left corner, you can see, I believe, let me see, are they changing? Yeah, they are. Okay, so you can see RGB is incrementing there, going up higher. Max RGB is based upon the current room light level. So it's chosen 68.5 as the maximum count for the RGB. So it'll just go up to that point on any of the three colors. And then they'll either go up or they'll go down. And if you kind of watch, you'll see, like there now red is starting to increase. And if I don't know if you guys can actually see the colors changing on this or not.
So far, it's just been white.
Yeah, this works. We need to see if we start doing these meetings at night. I'll redo this demo. Then you'll be able to see this guy much better.
Preview of coming attractions.
Right. And so it'll, yeah. So you see, so the red reached the 68.5. Now that's its max for now. Now it's raising the blue. So now you're mixing the red with blue, slowly getting more and more intense up. And then now it's went all the way down. Now blue is all the way down to 0. Now green is coming up. So now it's mixing full red with green, which is going to start out, well, it's going to kind of start orange and yellow, and then it's going to kind of gradually, so anyway, this is, I mean, this is a neat feature in that you can take your program and you can actually see it running in a sense. I mean, you're not actually running it on your Arduino, but you're seeing your code.
It's a simulated.
Running.
It's a simulated.
Yeah, it's a simulation of your code running, and so and it does a pretty. I mean, everything does seem to work. I mean, you take it off the simulator upload it into the Arduino, and it works pretty well. You just have to remember, if you've got things where you want to see stuff, remember to insert delays or something in the Arduino code, so that when it's running on the Arduino, it's slow enough that you can actually see those changes. If that's, like in this case, I've got that very top variable there is just a tenth second between increments. So it's going actually slower than that in this simulator. So the 10-second delay isn't really doing anything. But in the Arduino, you get about 10 changes per second of the intensity of the LEDs. And that's slow enough that it takes about, I don't know, a little less than a minute to go all the way from one end of the rainbow to the other end. And yeah, so anyway, it's pretty slick. I mean, it's like I like it.
So Steve, based on what you shared last night, as far as what you wished with this environment that worked differently, worked better, and then what you've talked about today. So what is the still missing piece
I'm not
with
sure
all of this?
I'm not entirely sure there is now that I appreciate the perspective from all of you, because I think what I'm seeing is that it's actually fine what it does. I don't think that I think this was something that I thought I needed because the other environment could do it, but I don't think so. Now that I'm really thinking about it, this is a sort of, I think this is kind of MakeBlock's equivalent of the monitor window. In other words, the ability to look at variables and see them in the simulation. And I don't, in the other environment, you're actually seeing them on the processor. I mean, you're sending that data from the processor back to the environment. But here,
it's just simulated. It's not.
Yeah, but it's
not real.
It's not real, but it works just like it was real.
Right.
So
that there in and of itself, Steve, is something. If you do take this environment, if you aren't already, and teaching youngsters from this environment, that's something to definitely mention to them. Is the idea about that it is simulated results that's being displayed and not actual.
Not actual. Yeah.
So,
although for in the grand scheme of things, would they care? Maybe.
Yeah,
maybe.
Right. Oh, I understand. I'm just saying that if any of them decide to pursue, programming later on in life, that's something to be aware of.
Yeah, this is kind of considering a foundational level of.
Oh, I understand.
Things.
I know.
And
it's a.
So it would definitely find the youngsters who have a bent for this sort of thing. I mean, if this is something that really intrigues them, it's like, okay, so then take this to the next step. So here's where you go from here.
Right. Exactly. And that's right.
Yeah. So
did you also run some other code on there while it's on the processor? It to a different serial port and then connect.
I don't think so. I don't think it's sophisticated enough to. It only allows a single connection at a time. So I've got, you see, there's those green blocks that are just kind of sitting there. That's an extension. And I didn't show you guys this, but then there's a whole bunch of library extensions that you can go out and grab to add more instructions to these things. For example, the DC motor shield. So to be able to, if you want to hook an Arduino up to the DC motor, like a 293 or a 298 motor shield, there's blocks for that. You go out, you grab the library, it just adds stuff. And I don't think they're not, because it's not in this program. They're not. No, they're not. I don't have those. I don't have those on this one, but you get additional block instructions then to allow you to, control motors. So you pick your motor, for example, motor 1, motor 2, motor 3, motor 4. And if you look on those little boards, they have M1, M2, M3, M4, and so you don't have to figure out any of that stuff either. You just wire your motors up, and then just go into their blocks and then choose the drop down for the motor that you want to run, and then it'll take care of making it happen. So yeah, so that's
Very nice.
yeah. I remember promising I would do this way a long time ago for you.
Right. I know. I remember you and I talking about this privately.
Yeah.
I'm glad. I'm
glad I finally got to it here. So
yeah, that's right.
I hope if anybody else has if you get any other interesting questions, reach out to me, because I've played around with this pretty extensively, and it's
So what is that spritz? One of the tabs that's down in the lower.
The sprite. So
okay, sprite.
So there's
okay.
So if you go to the MIT, let's see, MIT.scratch.edu, I think it's the web. I believe that's the website. So that's the Massachusetts Institute of Technology were the people that originally created the Scratch programming environment. So that was this whole block-based thing, and the sprites are a stage connected thing. So this area, this box over on the left where the variables are showing, is they call that a stage. And you can control sprites, or, if you remember the Commodore, some of you remember Commodore 64 days, sprite was a little graphical thing you could create, and then you could move it around, you could change colors, you could give it different characteristics. And so the Scratch environment itself is just a screen-based programming. So you can create things on the screen. You can create games, video games, things like that. Mm-hmm. And what companies like MakeBlock have done is they have taken that and then they've added hardware connectivity to that. So they've created robots that have motors and sensors, and then created blocks that are compatible with that environment to allow you to actually have interactions with the real world beyond a computer screen. Mm-hmm. So the sprites are just it's just another way of using the programming, but it's only things related to the screen. It doesn't go beyond the screen.
Right. Yeah, like a graphical LCD kind of thing.
Yeah. Mm-hmm. And so they've added, and so then the devices tab was what MakeBlock added to the list. You have background and you have sprites, and so you can control those two things with MIT's Scratch programming. Then MakeBlock says, okay, we want to control a robot. So then they added the devices tab, and then that gives you the ability to choose hardware devices that will then interact with the block code.
Mm-hmm. 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 Yeah, that sounds very similar. What you're talking about with these sprites or spritz, either one, and reminds me of the processing. Reminds me of the processing environment. A few years ago, excuse me, a few years ago, processing, along with the there's an IDE and there's a subset of the Arduino language that is specific to what they call processing, and with the processing development tied in with Arduino is that you can create games, you can create graphical interactions, and actually get sensor readings back and display information back using a processing type of environment. So what you're describing is very, very similar to that.
Yeah,
but within the M-block environment.
Yeah. So anyway, if anybody
I've been around with another of MIT's products, that's App Inventor. And if you guys haven't used that, you should check it out. Especially if you're it's really useful for those that are have a Android phone. They do have one. I think they do have one now for Apple. But I've been using it on Android phone for a while, and it's very helpful, very useful. I want to do a program on your put a program on your phone. I have one that I use as a remote control for a robot.
Huh.
and it connects up using the Bluetooth.
Hmm. Oh, these things have Bluetooth as well, by the way, too. So that is another way you can interface to these modules. So
Oh,
yeah.
you actually create an app on your phone,
Hmm.
connect that, and actually control it from your phone.
When you buy the kits, they have three different configurations. One of them is a two-wheel balancing kit. They don't talk about the software to make that guy work, but um, I think the firmware though it's part of the firmware. When you do the firmware update, that the ability to do that goes in there. But they have an app that you can run on your phone that allows you to drive the thing using touch control on your screen.
Mhm.
And then I think they talk about how you can create your own to do that. You can actually build your own interfaces on your phone to be able to do that. So that's a whole different thing. I don't even get into that with my teaching. I'm just sticking with the basic programming of making a robot that runs on its own rather than being remote control. Just because I have a fondness for autonomy rather than remote control.
Mm-hmm. Mm-hmm.
Yeah.
All right.
Yeah, what the fact that loading this up on a computer that was completely off kind of tells me, yeah, if I just turn this computer completely off, back on again, that things will work like they're supposed to. It could also be too that interacting with Zoom and other things,
Mm-hmm.
you get a lot. Chromebooks are not super powerful, right? So you get a few too many things running at once, and sometimes stuff just gets messed up. And
Right. Yeah.
my what I've typically done when I teach this stuff is I will usually have a completely separate computer that I'm doing the robotics stuff on, and then share off of that computer if I want students to see what I'm doing, and then have Zoom running on a second Chromebook so that they're completely separated from each other. Because yeah,
Mm-hmm.
it doesn't take much to mess up a Chromebook, I'm afraid.
Oh. Okay. Well, do we have anything else today that we want to talk about, or Q&A, or project sharing, or whatever? If not, we'll go ahead and close this out just a little bit early today. This has been a great session.
Yeah, it's been fun. It's been helpful and enlightening. So I
Right.
appreciate all you
Right.
all
Well,
of you
for
chiming in.
all of us as well. It's
Yeah,
always
Yeah.
yeah,
this
yeah.
idea about
So
group learning is always a positive.
yeah. So this is one of my little DC motor robots that I've got the DC the shield on top of it here and the Arduino Uno underneath. So I'll be I want to play some more with this and see how well I can get this to work. Got a little ultrasonic sensor on the front here, and it's too big for it's too big for mini sumo. It would probably work for a regular sumo, but I'd be afraid to go up against John's robot with this thing. So
Right off the,
yeah, I'm
Oh,
afraid I wouldn't stand much of a chance, even with the treads. I mean, it's like
yeah.
yeah.
Oh.
but but I have
Okay, guys. Well, I think. Oh, I'm sorry. I didn't mean to cut you off,
no,
Steve.
I have like about four robots like this that are conversions from various other processors to the Arduino Uno in a DC motor shield. So, and all of those theoretically should be pretty easy to use this environment to create whatever kind of program I want on them. So, so anyway, that was it.
Very good. Okay, well, I guess we'll go ahead and shut this down then for today, guys. It's been a lot of fun.
It has.
I'll go ahead and stop the recording.